Alrighty children, today we're going to look at find the sum of a series. Now the first thing we want to do here is we want to decide what kind of series it is. And so we're going to look first maybe at to see if it's arithmetic. And so I'm going to go 6 minus 2, which is 4, and 18 minus 6, which is 12. Those are definitely not the same. And so therefore it's not going to be an arithmetic series. Now most of you probably already knew that it's geometric. And so what I'm going to do is check to see if it's geometric. And I'm going to go 6 divided by 2, which is 3. And then I'm going to go 18 divided by 6, which is 3. Then I'm going to go 54 divided by 18, which is also 3. Which means that we do have a constant ratio of 3, meaning this is a geometric series. So now we're going to be finding the sum of all of this up to 12 terms. So you could write that out if you really wanted, but I don't really want to do that right now. And so we're going to just kind of figure this out, and we're going to use our equation because we learned in class that we have Sn, which is the sum of a series. A geometric series here is going to be equal to u1 times r to the n minus 1 over r minus 1. Right now, of course, this is also equal to u1 times 1 minus r to the n all over 1 minus r. So those are both possibilities. But with the bigger numbers, this one's a little bit nicer because we'll make sure that we have nice numbers. They're big numbers, and we don't have negatives for those that have a little bit of a fear of negatives. So we're going to go ahead and finish this one now because we know that the first number right here is u1. So I've got u1, I've got r, and then if I'm looking for 12 terms, that makes n 12. And so we can go ahead and put this in now. We can actually do the math. So we're going to find S12, or the sum of the first 12 numbers, which is going to be u1, which is 2, times the ratio, constant ratio, which was 3, to the 12 minus 1, all over r, which was 3, of course, minus 1. Now, with the 3 to the 12th, I don't really know how to do that. Well, maybe I could do it in my head, but it would take me a while, and you would get really bored of me trying to figure that out. So I'm just going to go ahead and put it into my calculator here. We're going to go I'm going to go 3 to the 12th. There we go, 3 to the 12th minus 1. And then I'm going to divide all of that, of course, by 3 minus 1, which is 2. And so I'll push enter, and I got 531,440. Now, it should be a whole number. If you ended up with something that's not a whole, an integer, if you ended up with something that's not an integer, you probably made a mistake because this is the sum of a bunch of whole numbers, and so therefore the answer should end up being whole number. If you got decimals and fractions, then yes, you might expect to have some type of decimal or fraction here. Unless you're going infinitely, which in that case, well, you may get something a little bit different. So there we go. That's the first question. Let's go ahead and look at another one because that was just easy. We need something a little bit harder, something a little bit more fun. So by now you know this is already geometric series that we're looking at. So we're not even going to look at the differences this time. Now remember here, this minus is, if this is supposed to be a series, it's supposed to be plus. So this is really plus a negative 3. So I'm going to go negative 3 divided by 9, which is negative 1/3. And if I do 1 divided by negative 3, I also get negative 1/3. And if I do negative 1/3 divided by 1, I also get negative 1/3. So I think we can be fairly confident that assuming that this is a series, because it gives us the S, then the R is negative 1/3. So from here we can go ahead and we can find a formula for Sn. So we're going to go Sn equals, and of course it's u1, and then we can go r to the n minus 1, or you can do 1 minus r to the n. It doesn't matter. And we go ahead and we put this here. We know that u1 is 9, so we say Sn equals 9, and then r was, of course, negative 1/3, and then n is n because we don't know how far we want to go yet, and all over r, which was negative 1/3 minus 1. So from here, if you wanted to find a specific term, you can do that. However, what we're going to do is we're going to go ahead and say, okay, if this series went on infinitely, if it went on forever and ever and ever, what would the sum be? Well, you may say, well, it's going on forever. It should add up to be infinity or negative infinity. Well, the answer is no, it doesn't. Quite simply because we talked about in class, and if you weren't in my class, let me just illustrate really quick. Let's just take a race. You start at the beginning, which is 0 meters, and we go to the end. This will be a simple 10-meter race. And let's say each time we go half the distance. And so the first time I travel 5 meters. Okay, and then the next time I'm also going to go half the distance, but I'm going to go half of what's left, which means that's going to be 2.5 because there was 5 left. And then let's go half again, which is 1.25. Now you can see we got a geometric sequence going on where r is 1/2. Now because r is a fraction, it's in between -1 and 1, we're going to end up converging. It's going to get closer and closer to that 10, but it's never going to quite get there. And so it's what we call a converging series, and because of that we can actually find out what would happen if it went on forever and ever. It would get closer and closer to 10 in this situation. So let's see what happens over here. Notice that in this equation right here, if r is a fraction, like let's just, well, 1/3 is fine, but if I get 1/3 and n becomes a really big number like 1000, that's going to be equal to 1/3 to the 1000 power, which is essentially 0. And so that means that this is going to go away, right? And so what we're going to end up with is a new equation. Now in this situation, I'm going to have Sn equals u1 times -1 over r minus 1, which is usually then rewritten to be u1 over 1 minus r. Multiply the top by -1, multiply the bottom by -1. And so that's what we're going to use here. We're just going to go Sn equals u1 over 1 minus r. And that's going to allow us to find out what would happen if we added all these pieces up. So we're going to take u1, which was 9, and we're going to divide by 1 minus -1/3. And that's going to give us 9 over, well, 1 minus -1/3, that would be 3 over 3 plus 1/3, so that would be 4 over 3, which would then end up being, well, 9 divided by 4/3 is the same thing as 9 times 3/4, which would be 27 over 4. And so that's what the sum would be if we were able to add them all up. Now that should make a little bit of sense because I'm starting at 9, and then I subtract 3, so I go down to 6, and then I add 1, so I'm up to 7, and subtract 1/3, so that's a little bit less than 7. So I'm going to be somewhere between 6 and 7, and you'll notice that 27 divided by 4 is 6 3/4. And so we do end up somewhere between 6 and 7, which makes sense with the pluses and minuses that we got there. Okay, so just remember that if r is between -1 and 1, not inclusive, and of course, as Hassan pointed out in class, r can't equal to 0 either. That causes all sorts of problems. And so it won't work. So no r equals 0. That's a problem. And so there we found out the infinite series. Hopefully you'll be able to do your homework. Good luck.